great honor because, Rob really kind of sets the leadership yardstick here at the Heart Institute. And so wonderful to actually enjoy his ability to actually, create a wonderful environment for people to collaborate. And, today is day 26 of, Jump In to raise money. And so this is my effort for bringing the heart connection. But a part of this is also opportunity for me to kind of review what we've been doing over the summer for this very, very major grant opportunity involving so many collaborators across not only the Faculty of Medicine, but in fact, the entire university, plus organizing other partnership institutions like McGill and the University of Saskatchewan. So it's really a fun effort. I learned a lot in the process. So I thought it would be great to actually share some of the thinking with you and get your reflections. And of course, we haven't started on this, but with the recent funding from the Heart and Stroke, we are already getting our kind of a preparation in place. So let me just see if this works. Yeah, so if I can put on, so how do I get into a screenplay? Apologies, I should be able to figure this out. I'm trying to get my screen into a full screen mode. And so I should, just mention that this is really a fantastic effort throughout the entire university working together on this opportunity. And it's really building a lot of strength within the university as well as many of our.
It's changing here if you want to use this.
Oh, okay. I see. Okay, so I can't see it myself on the screen. No problem. Okay, so apologies. I have to read this on the screen here. And so this is a sign of our time. It's the best of times. It's the worst of times. It was the age of wisdom. It's the age of foolishness. And it was the spring of hope. It's winter of despair. And of course, this was Charles Dickens' A Tale of Two Cities, a classic. But I think it's really actually timeless and really characterizes the moment we are in from a scientific point of view, from healthcare point of view. And really, it's a moment of reflection, but also of transformation. Because if you actually, what's happening here? I see, okay, now I see it. Okay, so it only changes on this screen here. Okay, so if we actually look at the scientific advances in medicine today, it's absolutely astounding. We can actually generate organoids of the brain, of the heart. We actually have synthetic biology, generate mRNA vaccines that really actually have transformed the face of the pandemic. We have tools like omics, and that can allow us to really actually characterize the entire genome, epigenome, RNA, transcriptome, proteome, and metabolome, and actually link them together in terms of big data. And we have tools to actually map exact molecular events like optogenetics, like molecular mapping using, imaging tools like Ben Rosting here, able to actually label a very, very specific molecules and actually localize them in terms of activity and transit in the human. And also in terms of big data health informatics, we have never before so many unprecedented tools to actually solve problems in biomedicine. So we should be way ahead, but look at the reality today. Okay, it's the first time in the last 50 years, life expectancy worldwide has decreased. And it's decreased by 1 year in 2020 and by 0.72 years in 2021. Of course, this is a result of the pandemic, and this is worldwide on the average. Several countries, including in the US, is actually more than just 1 year life expectancy. And giving up many of the gains we have made in the last few decades, and now we are actually back to starting point. And the burden of chronic disease is escalating. Of course, there's a huge interaction between the burden of chronic disease, such as brain and heart disease, and the COVID-19 pandemic. Patients who, with those conditions, are particularly the susceptible population, and they paid the price with their lives. And we also see the trend in cardiovascular mortality has been decreasing since Second World War. But in the last few years, as it flattened, it's completely stalled. And I'll show you data momentarily. There's been $43 billion in this week's Economist. Some of you have seen, it actually has a focus on mental health. And in fact, it's tallied $43 billion in the last 20 years has been invested in looking for solutions to Alzheimer's disease. 146 candidates from translation from basic laboratory to the clinic, 0 candidates has succeeded. And the health system are on the verge of collapse. We have a wonderful solution here in Ontario, right? We just actually ship patients out with chronic disease hundreds of miles away from their home in order to solve the bed problem. So we're really in a stunning moment in which we have lack of progress, and yet we have so many scientific tools. If you actually look at it in terms of reduction in cardiovascular mortality, and this is the maps provided by the US CDC, and on the left, you can see that the regions in the US have shown tremendous reduction in terms of cardiovascular mortality until about 5 or 7 years ago. And this has been stalled. The American Heart Association has actually had a presidential address 2 years ago to address this major problems that everybody is facing. If you look at a heart failure, and it's the same situation. I don't know if this shows up. Maybe it does, yeah. Then you can see this is in terms of the total death from heart failure. Of course, this is driven by the aging of the population. But even if you look at the age-adjusted mortality, it actually has been decreasing, but now it's actually stalled. Oh, sorry, yeah, that's over here. Oops, now I lost control of this one too. Oh, what is happening? Okay, this is wonderful. My punchline is coming up. Why does it? Apologies. There you go. Yeah, there you go. Okay. Yes. Okay. So we have a situation in which is characterized by this picture. What is this picture from? Lost in translation, exactly. So this is exactly the problem we have faced in terms of having tremendous scientific advance, but it is actually not translated into reality. And the question is, where are some of the issues here? And this is quite timely because just in three days ago, the Lancet lecture this year given by Dr. Victor Dzau on the left there, who of course actually visited us about 3 years ago before the pandemic to give the combined Gairdner and the Ottawa Heart lecture about advances in medicine, who is of course the president of the U.S. Academy of Medical Sciences and U.S. Institute of Medicine. And in fact, has given the Lancet lecture this year, has traditional medicine had its day? That we are actually failing in our goals. And the traditional medical education in the medical school has failed. And he has also offered a tremendous, wonderful solution here. And this is just the 3 days, just posted online in Lancet. And we'll talk about exactly what he said. But when we actually then look at chronic disease like brain and heart conditions are really, very much underscored by the challenges we just talked about. More than 4 million Canadians currently affected by cardiovascular disease and neurological disorders. And the economic burden is over $55 billion per year in Canada, thanks to Jody, who's in the audience here, providing a lot of these statistics. And the Canada healthcare system is disproportionately affected by brain and heart conditions. Of course, we know this, particularly during the COVID-19 pandemic. These are the patients who are the substrate of the condition. Mutations of the virus takes place in patients with these chronic conditions. And these are the patients who suffer the largest number of complications and they pay the price with their lives. And the brain heart conditions today still, even though they are actually very much connected and share common risk factors, are treated by separate specialties who don't talk to each other. And as our research by cardiovascular science, neuroscience, and mental health experts who are fantastic, but it's in distinct silos and not actually linked with each other. And in fact, I've been challenged when we were actually thinking of doing brain and heart conditions together by my own colleagues and by people who are actually reviewing our grants to say that the brain research is at its epitome. Cardiovascular science has never had greater success. You know, you put brain and heart together, it's just kind of a marriage of convenience. It doesn't address any useful problem at all. And I want to challenge that with a few cases that I personally see and others share as well. Here's a 72-year-old patient of mine who had a heart attack previously recovered. And we know that this is a substrate for development of heart failure, in which he did for the past year. Progressively now more limited with shortness of breath because his heart dilating is getting weaker. And we increase the medications. There are many state-of-the-art medications for heart failure, including beta blockers in particular, sacubitril, valsartan, amyris. And these are really, you know, sort of tremendous in terms of saving lives of patients. But the patients actually continue to feel worse. He actually lost weight, he can't sleep, and he really hates his medications. You know, this is very common. The commonest thing patient asks is, can I stop any of my medications? And so a lot of people thought that this patient is just, you know, one of these difficult patients, you know, who are non-compliant, you know, problem makers. But in fact, when I talk with him, there seemed to be a sense of despair and hopelessness. And I asked him the critical question, have you actually thought about killing yourself? And he said, yes, doc. And in fact, he has decided he will overdose plus cut his wrist. This is a medical emergency. I'm thankful to my colleagues at the Royal, and they were able to take him within 2 hours to admit him, and he's looked after. And I just saw him last month. He's now doing well, and he's actually shocked that he actually went through this, but he was lucky to survive. But we don't realize that heart failure affects 750,000 Canadians as we speak right now. 40% of heart failure patients have mental health challenges, and in fact, 30% have depression. 30% have cognitive impairment. But we generally don't actually talk about these things. And in fact, the recently funded CIHR Heart Failure Alliance, putting together over 100 heart failure specialists in Canada to actually solve this problem. The patient partner says the number one problem they have is actually mental health and cognitive impairment, whereas we focus on how to improve the heart function and ejection fraction. The patient says, we don't care about that. We worry about this. And so the group was speechless because we are not totally prepared at all. And then give you a case of a 68-year-old gentleman who's actually a high-level federal bureaucrat. You know, we have a number of those folks here. And he had diabetes, and he's actually done very well. But he was admitted with a heart attack. And he had a coronary angiogram, shows 3 vessel disease, which, you know, quite typical of a patient with diabetes. And by most guidelines in this situation, the patient really should undergo bypass surgery. But, you know, we obviously want a patient to be part of the decision-making process. So on rounds, we explain to the patient the risk of benefit of surgery, you know, versus angioplasty. Quite often patient likes angioplasty, but we say surgery is probably better for you, but you should actually talk with your family and let us know, you know, how everybody decides. And I went in there the next day, you know, the patient is smiling, even knows I'm Dr. Liu, but then I found out what he does is he actually knows my name is on the board. He knows I'm Dr. Liu. But he actually had no recollection of anything that we said yesterday. This is really strange. You know, I checked with the family, and in fact, patient is getting more forgetful, easily lost and upset. And when we checked his mental faculties using the MoCA test and Montreal Cognitive scale is 22 out of 30. So this is mild cognitive impairment. And unfortunately, this is very common within our population, but nobody does routine mental health, you know, assessment, except, you know, Jody is actually doing a study now. So coronary disease is, of course, the number one killer. In fact, about 30, 40% cognitive impairment. And then the challenge, of course, is that when patients actually go for bypass surgery, when they go on heart-lung machine, their cognition deteriorates further. Such is the challenge. And here is a 45-year-old female who was previous diagnosis of schizophrenia. And since age 30, has originally presented with social isolation, lack of motivation. More recently, has more advanced symptoms such as hallucination and fragmentation of thought. The patient was prescribed different medications. Ultimately, clozapine and the similar medications had the best effect. But we know that many of these psychiatric medications, whether it's actually for major psychiatric conditions or SSRIs for depression, for anxiety, in fact have major cardiometabolic challenges. So this patient, very typical, in fact, of many of these patients, gained 18 pounds in the last 2 years, developed diabetes, and presented in hospital with acute myocardial infarction with advanced coronary disease. And most of this is likely due to the treatment they're receiving. And this is really actually a new epidemic, because mental health issues affect 6 million Canadians. And I'm sure you know about the major challenges we have. And COVID-19, of course, really actually further exacerbated this problem. Schizophrenia is about 1% of the population, and 20 to 30% of these patients have cardiometabolic risk to start with, of course, totally aggravated by the medications that they actually receive. And the schizophrenic patients have life expectancy shortened by 15 to 25 years compared to the general population because they die of cardiovascular death. But do we actually know how to look after these patients? Most of us actually try to avoid patients with mental health problems because it's too complicated. They're difficult patients. We don't understand this. Why does this happen? These are huge gaps. Even though we pat ourselves to say that we are really good at treating cardiovascular disease, we know exactly how our patient is going to turn out. But in fact, if you actually look at this table, and thanks to Michelle Campbell and Alison Hosey for putting this table together, in fact, if you look at atrial fibrillation, 500,000 Canadians being affected. And in fact, we know stroke, generally is between 2 to 4% per year. But what is less recognized is the fact that dementia is a major consequence of this. And Jody again is studying this, and we understand atrial myopathy, in fact, is substrate for this. And the heart failure we talked about earlier, stroke, of course, is associated with coronary disease. Stroke patients don't usually die from stroke, but actually die from cardiovascular complications. And the depression, again, affecting huge number of patients. And again, a major problem in terms of cardiometabolic complications. So we have huge gaps. And then the thing is that this is not, it's out there in the open, but nobody tried to recognize it simply because it's kind of complicated. So we do know that the heart, brain are actually totally interconnected. And we know in development that they develop together, they share the same risk factors. When you actually challenge one system, the other system also is also affected. And so the challenge is that the brain and heart disease is the #1 cause of disability for Canadians, and also #1 cause of death worldwide. And yet these are siloed in terms of research as well as care, and as well as the inequities in health that's actually exacerbated because of the failure to recognize this kind of activity. And so what we want to do is really actually bring attention to this major gap and actually find solutions, and that the brain and the heart should really actually be regarded as a single functioning unit. And we need to actually uncover this connection between the two. And in fact, now we know there are actually common, for example, novel diagnostic tools allow you to diagnose whether the patient has any of these conditions at early stages. There are imaging tools that can actually recognize the linkages between the two. And the treatment may, in fact, lie in this intersection. We know today for dementia, even though there are no specific treatments for Alzheimer's, yet we know exercise, addressing high blood pressure, addressing diabetes makes a difference, right? So it's already linked in. And we know the microvasculature is actually connected between the heart and the brain. So these are opportunities that are unique as present at the moment, and the taking advantage of major tools can allow us to really actually make a difference. And so the Brain Heart InterConnectome project is an opportunity for us to actually bring together this strategy for early prevention, early detection and treatment for these shared conditions. And so it's a paradigm shift of linking the two conditions together, leveraging, of course, already existing excellence in cardiovascular and brain mind research, and also patient care here at the University of Ottawa and all the research institutes associated with the hospitals, but also bringing in additional expertise from McGill University, University of Saskatchewan, as well as the research institutes from University of Toronto, particularly CAMH, the Center of Addiction and Mental Health, as well as Sunnybrook Hospitals. But we are not doing this alone, and we're not doing this for the first time. If actually, and thanks very much to folks at the University of Ottawa, also Faculty of Medicine, to actually get this data together to show that, in fact, in the last 7 years, the external leveraged funding from mainly tri-agencies, for example, totaled $590 million in external revenue in these combined domain. Altogether, I think for the entire university is over $1 billion, but you can see that about 50% is actually in this area. And targeted institutional investment, over $100 million. And similarly, in terms of CRCs, there's a focus, in recruitment in these areas, as well as supportive training programs. And this is building really actually on foundations of success. For example, back in 2000, early 2000 to 2013, Network Center of Excellence in terms of the stroke network led by Tony Hakim, that actually changed how stroke care is done, not only in Ontario, but across Canada, in fact, worldwide. And this is really actually a foundation that actually linked the brain and the heart together. In fact, he emphasized the importance of this linkage before anybody else actually recognized that. And this is followed by Canadian Partnership of Stroke Recovery, funded by the Heart and Stroke Foundation based here, and then Canadian Vascular Network shared with Dr. Duncan Stewart, funded by CIHR, particularly studied the microvascular link and also cross-regulatory link between the brain and heart. And this was followed more recently with the cardio-neural mind CFI, as Rob mentioned earlier in introduction. Thanks very much. And together with Ruth Slack, and director of the Brain Mind Institute, and most recently in terms of the impact work from Heart and Stroke Foundation. Now, this is all very nice, but it's nice to actually get some money for it. And so a unique opportunity came up. And in fact, the federal government has made an announcement late last year that this one opportunity for $1.4 billion to fund university-led excellence in research. And I call these the election bonus because it occurs about once every 6 years. And so that's how 2 election cycle. And usually it's announced just prior to a difficult election. And so, this was, I think about 2 years ago. And this was announced prior to the election. And but the government didn't get reelected. So I guess now the money is rolling out. And so this is an opportunity that each university can get one proposal. Doesn't matter how big or how small you are. And this lasts 7 years. And we calculated the average ask is about 100 million, per university. And of course, bigger university will ask for more. And so it's aimed to build strength in areas of excellence. So you can't actually start from scratch. This has to be building on existing strengths. But the key is that you must be able to demonstrate at the end of 7 years, you're within the top 2 to 5% of the world in this area. And you need to have to show a path to get there. And so this is all about global leadership, but you can't do it alone either. If you actually want to devote yourself in the area, you need to actually bring other world-leading institutions in Canada along with you. So for example, if we're doing green energy, we need to make sure that the best green energy universities in Canada are also part of the team. And that's the reason, we have McGill, Toronto, and Saskatchewan. And you need to create an environment to pursue the best in talent and advance strategic opportunities, but it's very important. It's not just, doing publishing and doing research, but it actually must have economic and quality of life impact for Canadians. And you need to have forward thinking. So you actually, through this process, transform the institution. So that's a pretty big order. I don't think anybody can succeed in changing a university, but this is asking you to do it with a little bit of money. And then we have a number of important networks that's already existing as part of the application, bringing teams together really across Canada in many, many domains, whether it's in Indigenous health, in clinical trials, in heart failure, in cognitive impairment, in genetic diseases, etc. So we have to now, University of Ottawa need to decide on area of priority. There are many candidates considered, obviously, there are many areas of strength, but we're very, very grateful that at the end of the day, Dr. Sylvain Charbonneau had enough confidence in brain and heart area of research that allowed myself and Ruth Slack to work together to actually pull forward brain and heart InterConnectome as the proposal on behalf of University of Ottawa. And so we need to actually start to work very hard. This is super competitive because every university putting forward their best team. And so so we need to prepare for letter of intent. The letter of intent is submitted in April of 2022. And we won't find out the result, for at least another over 2 months. But the moment we submitted LOI, we actually started working on the full application because the full application is due end of August. You really actually have no time. It's only at the end of June that we found out we had a green light to go forward to the full application with, quite encouraging reviews. So we're very grateful for that. But the entire summer, is actually just working on the application itself. And final version was submitted on August 31st, late in the afternoon on the deadline. And I'm so grateful for so many people working together with us. Many people ask me how your summer was. It's a blur, and I can't remember how the summer went. But unfortunately, I bugged so many people. Their summers went the same way. And these are some of the key core personnel folks in the project. I won't use them else here. So very fortunate to work with Ruth Slack, who's the director of Brain and Mind Research Institute, and brought together really, her talent, the team into this. And we have, you can see that, we have young and more senior investigators. We have people from the University of Ottawa, the different hospitals, but also outside as well. And so, for example, Dar is a clinical trialist in stroke and already doing a lot of work, with the Heart Institute. And Jody is here, so who really actually is the archetypal researcher in terms of brain and heart interface, and really actually, served a tremendous inspiration for all of us. Dr. Hans Lockmuller is actually a neuromuscular expert who has actually experience with this type of application from Europe, and really actually brought a lot of expertise, and of course also work with us, in terms of neuromuscular cardiac clinic here as well. And Katie Rayner bringing a number of really scientific innovations, particularly on the inflammation and vascular side, into the application. Tracy Vaillancourt is actually a tier 1 CRC in education and the psychology as well as health. So it's actually fantastic, and her area of expertise is actually on bullying and also the school system during the pandemic. And she actually headed up a royal commission to actually specifically recommend how education should go forward during the pandemic. Dr. Malcolm King and his wife Alexandra King runs the best network in terms of Indigenous research in Canada, probably in the world as well. And we're very, very lucky to have them as part of our team. Ian Graham, of course, is really actually the guru in knowledge translation, and he actually directed the entire knowledge translation program. And Rianne Toyes, who was previously at the University of Glasgow, heading up the Cardiovascular Institute, and now is the Chief Scientific Officer for Research Institute at the McGill University. And so we're so grateful that she actually is part of our team as well. But this is only just some of the team lead. It involves, hundreds of investigators, and we're so grateful for everybody's contribution. And the application is also complicated. The scientific strategy is 30 pages with many appendices. Implementation plans is 15 pages, and budget justification is 20 pages. And also you need the individual partners. We started with 24 partners. We end up at 48, and with the partner institutions over 50. And each one of them, requires actually detailed budget calculation in terms of matching. And so it's really a huge piece of work. I'm so grateful for the tremendous help from the both the University of Ottawa as well as the Faculty of Medicine. Terry Campbell from the Professor Charbonneau's Vice President Office. Particularly shout out to Alison Hosey, who of course the Heart Institute before, but she really actually represented the university and coordinated many of the application components. And Charlene Clow from Faculty of Medicine, particularly looking after the budget component. Michelle from here on the partnership aspect in terms of bio sketches. Mohammed from the Faculty of Medicine did a number of the performance monitoring as well. He's artistically very talented, did beautiful figures for this application. And Melanie Ryu did a really great job on the implementation plan, plus many others, who really helped out. And the application itself really evolves around 4 linked themes and 2 foundations, and with many cross-cutting components. Our total asset $110 million over 7 years. And this includes the theme 1 of biomarker and imaging tools. Theme 2 is on the therapeutics. Theme 3 is precision prevention. Theme 4 is innovative health systems. And with many cross-cutting themes, including things like training, EDI, knowledge translation, and commercialization. And the foundations include the clinical epidemiology deep phenotyping component as foundation 1. And Jody, in fact, led that. And then we have foundation 2, which is basic science and the discovery component. And Ruth Slack and Katie Rayner led that component. And the entire program represents the integration of these pieces. And just to give you an idea, when we are doing a planning session, for example, for foundation 1, not only the core personnel is involved, but also we need to actually invite, sort of all the additional folks. Rob Inlands is certainly involved in this one. I think also the biomarker imaging one as well. And so we really, had the opportunity to work with many, many talented people spending their summer with us to actually do this. And for the strategic planning session, it's not, just to bring my favorite project, to the fore and hope we can get some money for it. But in fact, this is actually thinking on a much bigger scale. This is really actually thinking of the community, because you need to actually think of how to actually have breakthrough impact for the area that we're working on so that it can be globally leading, and how we can, at the same time, impact on the well-being of Canadians, promoting Canadian economy, and also ensuring equity, diversity, inclusion principles are included in every stage of the application, ensuring integration, knowledge translation, commercialization, and relevant partnerships. So really actually fairly complex set of discussion in order to optimize all these components rather than just kind of doing a single project. I just give you a little bit of highlight, because each one of these themes are, have many, many subcomponents to it. But just to give a highlights on the biomarker imaging tools, it's really actually about novel biomarkers that can actually detect brain heart disease early. We actually already have candidates that potentially can be submitted to FDA already, working with Rush Diagnostics for many years. And then have tremendous functional MRI tools to look at brain and heart linkage. And some of this is led by Matthias Friedrich, from McGill. For example, they already have oxygen sensing strategies to look at the brain and the heart. And they actually show that within each individual, for example, patient with heart failure, that the brain oxygen sensing dysregulation is completely coupled to that in the heart. And many of these, in fact, are already commercialized and standardized, now used, in different centers. Microvascular mapping, inflammation, and some of these, particularly on the PET aspect, is led by Ben Rothstein here, and all the Rob DeCamp and the Rob Beanlands. This is really actually, one of the obviously major unique strengths of the application, but also MRI-based molecular imaging ligands. But the key that we want to do is actually being able to integrate the biomarker and the imaging together with the AI strategies so that we can actually do this for patients on a much broader scale. On the therapeutic aspects, it's not only in terms of, for example, using organoids to screen for candidates and to develop novel biologics. And keep in mind, Ottawa, in fact, have one of the best biomanufacturing systems here because of John Bell's, expertise. And so we're leading from that area. And that's a unique opportunity for us to have candidates, produced in large quantities for clinical trials. But also we have other, sort of tools that's a little bit non-traditional in terms of pharmacological. You have music, exercise, psychological, and sleep interventions. And as you know, we have the Music in Health Research Institute with Gio Como, being the leader. In fact, it's the WHO, sort of a center for music and health research. And so that is going to be actually evaluated in different clinical trial settings as with customized opportunities, because music is actually tremendous in terms of prevention, for example, for the aging population, but it's also extremely useful in terms of promoting exercise and other aspects, which is totally underexplored in health at the present time. And also with our indigenous communities, particularly in this two-eyed seeing strategy, in which we can actually take the traditional indigenous healing principles and practices which are successful, for hundreds and maybe 1,000 years, and together with Western medicine to really achieve unique harmony and synergy. And also in terms of knowledge translation approaches to particularly engage ethnic groups and also marginalized populations, because usually they are the population that's not accessing healthcare, and you really need to actually work with the community to actually succeed in that. And here's, for example, indigenous research ceremony, circle of healing, involving the elders to actually identify strategies of research collaboration and innovation within the community, by the community. And then we also have targeted precision prevention strategies. And one of them is actually school-based. Young kids, whether they are having psychological trauma or physical trauma, can really actually have impaired development and be at risk for early brain and heart complications. And the Tracy Vaillancourt's team, in fact, developed tools and the education system to build resilience in young people so that they are actually able to recover and, in fact, prevent these type of tragedy from occurring, and therefore build healthier populations. And also we're using big data to actually do micro-targeting of risk. And in fact, this is one of the challenges opposed to Chris Soon, who's our new Canada Research Chair, jointly recruited between Telfer and the Heart Institute. And that is actually using health data, risk distribution, health outcomes, but together with geography, with climate, traffic patterns, and the socioeconomic distribution, you can actually identify risk within each neighborhood, and then being able to then deploy strategies to actually target those risks engaging the community, engaging the primary care, engaging the Ministry of Health, engaging public health, so you can actually much more effectively target those risks rather than just say, check your blood pressure at your shoppers and, make sure you know what it is, right? And so then we also have innovative tools in terms of guidelines and also in terms of specific strategies. And what we want to do is really actually be able to target, and we change from reactive system in the healthcare, just emergency entry based treatment for brain and heart conditions to preemptive, so that we actually understand where the vulnerable periods are in a person's life trajectory and being proactively build strength in health in those settings, whether that's in the education system in our youth, early adulthood when the risk factors particularly become manifest, and it can be mitigated to change in natural history or early disease detection, rather than looking at the end stage disease all the time. And the last aspect is really actually a new model of care in a learning health system. And this is rather than having kind of a specialty driven driven program, we now actually have a patient-centered primary care coordinated public health partnered hub and spoke community care model. And so this may sound very complicated, but in fact, University of Ottawa is actually a leader in this, and in fact engages kind of a global collaboration network on this. Simone Darouk and also Sharon Johnson and many of the primary care investigators here have major network grants in this whole area in terms of primary care, chronic disease intervention. And so we really actually are very fortunate to have their expertise. And so then you can actually have the tools to actually map the assets within the community, but also identify using big data the gaps of need in the community and design tailored solutions for that community. And this is what we are working also with Health Ontario and also Ministry of Health in terms of potential funding to specifically to target these type of solutions, and so that you can actually maximize the resources and its impact on what's actually needed in the community. But of course, this is particularly important in those communities of need, whether that's in the ethnic minorities or socioeconomic challenges communities. And then the big foundations include Foundation 1, that's big data, deep phenotyping, and this is where one can actually integrate these very large databases, and that can come up with predictive tools, and they can become digital bedside decision aids in terms of tailoring treatment for the patient. And the Foundation 2 is fundamental mechanisms, including clinical models of brain and heart disease, and also the integration of omics, whether that's the cell at the organoid at the models to the human level, and actually identify potential mutually regulatory pathways as candidates for biomarker or therapeutics. And the knowledge translation, so we also champion this model. Of course, this is a really credit to Ian Graham, who's sort of passionate on the concept of integrated knowledge translation, and so that the knowledge users are actually helping to drive priorities. So rather than, so I call this the whole model of solution making, because the usual paradigm for science is that we, sort of generate some model in the basic lab. We do some intervention. Unfortunately, that's kind of what we're doing at the present time. And you discover something, and then you say, there must be a good use for this, right? And then you try to translate to clinical. Well, certainly Alzheimer's disease, 146 candidates later, we have zero impact. And we know that many basic discoveries don't translate. Part of the reason is because we just assume that we actually know that, what's important in the mouse must be good for people, right? It actually should be the other way around, in which we actually say, what is really needed? What's the gap in the clinical setting? And where do we actually need to have solutions? This is where we use, sort of the clinical biomarkers as guidance, use clinical imaging tools as guidance, so that we can actually find relevant solutions to real problems, and so that the answers can actually have an impact. So this is the new model, and this is the integrated knowledge translation strategy. And so we have patients, partners engaged in every stage of the development of the program, and we have methods to actually produce real-time research results to actually be able to translate into the clinical setting to actually affect measurable change. And we need to actually have a capacity building so that people are comfortable with this kind of research rather than the traditional kind of the push model of research. And I may just kind of mention a little bit of an important, unique area in which we're really building a lot on, and that's big data and the collaborative data portal. And so that the data portal, which will be based here, but really actually connecting all the major sources of data, will include, for example, the latest clinical guidelines, major clinical trials, so all the evidence used for providers. But at the same time, we will actually have, from the same source, scientifically validated information in this age of misinformation. We're particularly mindful that we have accurate information for patients. And so these are the tools for self-care, for really actually information about the brain and the heart conditions and the solutions, the type of clinical trials that the patient can participate in. And this will be done together with the Heart and Stroke Foundation, Brain Canada, who are already major partners with us in this application. But then the more important one is actually the deep phenotyping data in terms of the omics, but the clinical outcomes in which we actually link everything together so that within the same patients that we are studying today, we will actually have the clinical phenotyping, we'll have the imaging data, we'll have the biomarker data, the genomics, and as well as the treatment results, all within single setting. And so that these can be cross-referenced and cross-analyzed. And we're not doing this alone simply because this is already being actually very well worked out. For example, Montreal Neuro is a world leader in terms of the big data integration. And because they had the previous CFREF for $85 billion to get this figured out. And so now Montreal Neuro is the hub of not only all the data across Canada in terms of neurological imaging, pathological, molecular data, but in fact, they have the entire European Union as well as all the NIH networks. And I think just last month, they have the UK Biobank, right? So the world's best data in these chronic diseases can be integrated. And Montreal Neuro is doing this, and they are doing this with us as well. And thanks to Kelly Colby, because we have joint grant on open science between brain and heart. And we're so grateful that Montreal Neuro has decided to work with us on that. But this data is also linked to the U of T, huge data resources, because the U of T's major resources actually cited at the CAMH. They have invested, I think, $19 million into the infrastructure. They have some of the best tools and integration with clinical data, of course, all the mental health data across Canada. So we have the best of neuro, we have the best of mental health, and we have the best in cardiovascular, and linked together, and also with the other University of Toronto and other institutions. And so that the idea here is that the data are integrated so that you actually have some of the latest AI and biostatistical tools, and that the investigator, depending on the level of expertise and also level of access, will be able to actually form collaborative research groups in silico. And you can do this all around the world. And we aim to be the first, hopefully the only brain and heart data portal to do this. So we do believe that with these programs, we are able to deliver apps, novel biomarkers, imaging tools, even strategies, for other type of opportunities. And so maybe I can just mention that we have already partners engaged in the process. In fact, 48 partners and already 115 million commitments, sort of on top of our 110 million ask. And maybe I think it just, EDI is totally integrated into every aspect of the application, and as well as training as a key component of this, because this is a new way of doing research and a new way of delivering clinical care. Because I want to come back to Victor Dzau's paper, which was just published 3 days ago, in terms of how academic medicine needs to change. So the traditional paradigm of just looking at training to look after one patient is no longer sufficient. This has been proven certainly through the pandemic, because the healthcare system is collapsing based on the old approach. So Professor Dzau indicated there are 4 major priorities in how the academic medicine needs to transform itself. Number 1 is that one need to actually come in with convergence science and the clinical practice. So it's no longer kind of a one, sort of a basic model and mechanism, and then you try to apply it to that one single patient in front of you. But in fact, you need to actually bring all the different tools together, including ability to actually look at the non-communicable diseases as an integrated whole, like what we're doing now. And it actually needs to incorporate social determinants of health, because that's way more important than many of the drugs that we can actually give to the patient. And these things need to be part of the assessment of the patient population, but it's also part of how we develop health programs. We need to realign data science and digital technology as the entire process of how we actually link care outcomes and public health. Right now, public health seems to be, something that's a kind of left at the end of the medical education, but now it needs to be front and center, and needs to be actually part of the entire medical education and practice. And so that the research and decision support need to be integrated. And so we're very happy that we have proposed, and in fact, we'll be implementing primary care together with public health, together with community in a patient-centered model. And the community engagement and seeking equity is going to be critical. Academic health science centers cannot just work in isolation. In fact, it needs to be part of the community. It needs to actually work with the community to demonstrate how academic health centers can actually address the equity problems, address community needs, and demonstrate how future of healthcare is going to be delivered. And that the training of future workforce is going to be requiring individuals conversant with all these tools and approaches and philosophies, and not just looking after one patient at a time, and not just doing kind of a basic to clinical translation. So I think then in the end, brain and heart conditions needs to be treated integrated entity, convergence science to transform chronic disease care from reactive to preemptive, and to build resilience for the next pandemic. And new tools such as digital predictors, biomarkers, imaging can detect disease early to allow earlier mitigation and targeted prevention rather than just broad prevention strategies. And that we need to actually have innovative patient-centered, community-engaged care to build on big data to allow continuous learning. Thank you very much. And I particularly want to thank Sylvain Charbonneau and Terry Campbell for the support of this effort and working with Ruth Slack. Special shout out to Allison Hosey, who really actually helped us to write the entire grant. Charlene Close, I mentioned earlier, Tracy, but also Guy Rouleau from Montreal Neuro, who really actually endorses the whole approach and has been truly a tremendous collaborator. Thank you very much. As I should stay here.
Thanks, Peter. Can you hear me? All right. Apologies. Apparently, my intro wasn't heard online because I didn't have the mic on. But anyways, obviously extremely amazing to pull all this together, and ambitious project. But I think you have to think big and look big to be able to achieve things. We don't have a lot of time, but I will just ask maybe one sort of broad question.
Sure.
And if you look into the future with this project or this type of project, How do you see the knowledge gained helping the 3 patients that you gave examples for?
Oh, that's a great question. Yeah. So I think this number one is that the entire conceptual process, right, of thinking organ alone needs to change. So unfortunately, we're at the Heart Institute, right? But, we already have folks like Jody telling us that we need to actually screen for these almost like sister connected conditions, right? We need to actually have the paradigm change and have the confidence as well to know that if we actually address those conditions, patient will actually do better. Right? We always only focus on the heart, and we know that it's not adequate. And so I think that's number one. Number two is that how we educate our trainees, even on the research side, right? It's not just heart focus. Well, imaging is very typical, right? When you actually look at the different conditions, we look at the whole body, right? When we're dealing with things like inflammation and things like that, right? It's not isolated to the heart. And so I think we need to actually be comfortable with that, and then teach the trainees to actually realize, the world is more than just a heart or just the brain. But in fact, these organs work with the rest of the body. And that's how the patient, can function well. And when we address all those aspects, I think the synergy actually will change the patient's outcome as well. And then the third part, which is really important, I think is able to actually engage the patient's community. Right, right now we just talk with the patient and assume everything else will look after. But we know some of the biggest barriers, right, whether it's non-compliance or poor outcome, right, has to do with their family, their community, how much support they have. We try to we know our social worker, kind of do the magic thing. But really, we should actually be proactively engaging this as part of the conversation, right? And we need to actually understand all these aspects before we actually, prescribe treatments. And that when we actually work together, because the patient is our partner, public health is our partner, the community is our partner, family is our partner. When we actually, everybody works towards the same goal, I think this is really where the health, right, can be improved for everybody. Yeah, so I really think that this is a perfect moment in time. We kind of know some of these things are, needed, but we never kind of can break out of our own specialty box, right, to say, my goodness, this is actually the way to go, rather than to say, maybe, we'll try this, we'll try that, right? So I think this is a whole different system that we can think about.
Great, thanks, Peter. And any other questions from in the room or online? Well, with that, Peter, congrats on pulling this together and for recent funding successes, and thanks for your leadership and driving this forward.
It's all teamwork. I learned from everybody. It's just been amazing. Thank you. Yeah.
All right.